Alright, let's start. So today, like I said, we're going to talk about some new things. You might have heard of factorials before. We'll talk about those. Permutations, combinations should be pretty new to you guys. I don't think you go through them at all in geometry, do you? Remember permutations, combinations? No. Alright, so those will be new to you. They kind of go together, but you use them in different instances. So let's get going on that. First things first, what the heck is an exclamation point? Right? An exclamation point is the mathematical sign for factorial. Now, a factorial, the n factorial, is the product of all numbers n and below. So anytime we say like 5 factorial or 10 factorial, it means we're going to take that number and multiply it by every other number that is below it. All right, that's what a factorial is. So like the first one here, our example 5 factorial would be 5 times 4 times 3 times 2 times 1. Right? It's taking that number and multiplying it by every single number below it. Now what would that equal out to? Does anyone know? 120. 3 factorial would be 3 times 2 times 1, which would equal 6. What?
Why do we do this?
That's a great question, and one of the examples we're going to do in a second is going to tell you why.
This kind of sucks.
Okay? 10 factorial.
10 times 9 times 8
Do we
times
really
7
need to include the times 1?
What?
Do we really need to include the times 1?
Technically, yes, because it's that number and any number below it. But when you do it, obviously when you multiply by 1, it doesn't change anything. What is 10 factorial? Didn't do their calculator?
3,628,000.
Would you get 3,628,000 and what? 800. Alright. Now, instead of having to type all that out, there is actually a button on your calculator. Right? If you go in your calculator, if you hit the math button, you go over to probability, P-R-O-B, the fourth one down is a factorial. So if you hit it, it'll pop an exclamation point out there. So if I want to do like, let's say 10 factorial, $3,628,800. Right? So there's a button on your calculator. You don't need to do it by hand all the time. Yeah. Did everyone find the button on their calculator?
Yes.
Okay. Now, applications. Now it's like, why would we do this? Right? How many ways can you arrange 15 pool balls? Well, I want to arrange 15 pool balls.
So many.
I get 15 to pick the first time, times 14, times 13, times 12, times 11, right? All the way down to choosing that last one as 1. 4, 3. Now, right? Because I can choose from 15 different balls the first time, 14 the second time, 13 the third, 12 the fourth, 11 the fifth. But why would we do all that work when we could just do 15 factorial, right?
When you get this,
What happens when you get what?
it gives you like 1 point whatever each.
So what do we call that?
Scientific notation.
Scientific notation. So we can write it in scientific notation. Liam, what'd you get on that calculator?
1.3076743688 each one.
So 1.3 times 10 to the 12. Right? Scientific notation. It's fine. We get big numbers all the time. Scientific notation is perfectly fine. Alright? Now, obviously not everyone's going to be arranging 15 pool balls all the time. Right? But some of us, if we were good enough, I don't know. I'm not sure, you might not want to listen to this.
You're probably JV all 4 years.
False. I was varsity 3 years, but thank you.
Oh, and freshman. Right?
Yeah, I did play on a freshman team my first year. Thank you.
My sister's boyfriend was JV tennis all 4 years.
It's tennis. How many people do you think you had to compete with for varsity?
Oh, enough.
Apparently at least more than
one.
him. Yeah. All right. How many ways can you arrange 5 baseball trophies on your shelf?
120.
Well, why don't you guys figure this out?
5 exclamation.
Five exclamation points.
5.
Right? We have 5 to choose from the first time, 4 the second, 3 the third, 2 the fourth, 1 the last, which is the same as 5 factorial, which is 120. 120 ways. Right? So those are why factorials are important. That's why we use them. Okay?
It's like you're just shouting the number 5.
What?
It's like you're just shouting the number 5.
5.
5.
5.
5.
All right. Just shouting the number 5. That's one way to think about it, I guess. All right. That's factorials. Let's think about this problem here. Suppose a film buyer has 11 films for an 8-screen theater. So there's 8 screens in this movie theater. There's 11 different films that they have that they could show. Since the screens are in rooms with different seating capacities, the film buyer must decide on which screens to show the movies. How many different arrangements are there for 8 screens to show the 11 movies? Well, if these are my 8 screens, I don't want to show the same movie in 2 theaters, right? That defeats the purpose. Doesn't make any sense, right? So the first screen, how many different movies do I have to choose from?
11.
11.
10.
Then 10.
9.
Then 9.
8.
Then 8.
7. 6. 5. 4.
So this one's technically not factorial, right? Because I don't do 3, I don't do 2, don't do 1. But I can multiply these parts together to figure out how many different ways I could show it. How many different arrangements I could have for all the different movies. It's going to be a lot. 6,652,800 arrangements. Right? So it's technically not a factorial, but it kind of acted like one, didn't it? So we don't call them factorials. What we actually call them is permutations. So permutation, that's the next thing we're going to talk about, right? It's one of the new things we haven't talked about before. When a group of objects or people are arranged in a certain order. Circle, star, do whatever, highlight, do whatever you need to. With permutations, order matters. We're going to see combinations in a second. Order won't matter. But a permutation, the order absolutely matters. Alright? So that's how we're going to be able to tell the difference between the two. One of them the order is going to matter, one of them the order won't matter. So the way we find out how many arrangements we have, what kind of orders we do, we have a formula. P of n comma r equals n factorial over n minus r factorial. Right? That doesn't make much sense to us right now. Right? What that is there's n objects. So like we said, there's 11 movies. And they're taken r at a time. So like they were taking 8 movies at a time. So what we would have done would have been 11 factorial over 11 minus 8 factorial. So what that does is it divides out the numbers we're not using. Does that make sense?
Yes.
So if we go back, like I said, to the movie question, we had 11 options, and we could pick 8 of them. Right? We had 11 different movies to pick 8 for. So the number of ways to arrange 11 things, taken 8 times, would have been 11 factorial over 11 minus 8 factorial. N over n minus r factorial. Does that make sense? Okay?
Yeah.
Did you do that in your calculator by chance?
I'll try it.
You'll try it? Thanks, Q. Right? If you want to put in there, you can do 11 factorial over 3 factorial. So 11 minus 8 is 3.
What do you got, Q?
Wait, I'm not done yet.
You're not done yet?
Oh,
He is not done yet.
What the heck, man?
Figure it out, Q, jeez.
Jeez, I'm sorry. I'm just slow today. It's not working.
Hey, Paige, did you get an answer?
I just did.
You did?
Same answer?
It should be the same answer. Did you get the same answer
Yes,
as
I
before?
did.
Awesome, yeah. It should be the same exact answer we got before. I mean, hopefully it was. It should have been 6,650,000 or 25,800. 52,001 and 2. 52 or 25? 52? Okay. Alright, so you should have got the same answer you got before. Now, really big key here. It can also be written, that's really small, I'll rewrite it. So we said it's P of NR, right? We said that's how it's normally written. It can also be written as NPR.
Why?
Because that's how it's going to pop up in your calculator. And that's how you're going to put it into your calculator so you don't have to do this all the time.
Come on, I'd rather do that than do that.
So, this means the same as this. Two different ways to write it. It means a permutation. Alright? So if you want to use your calculator, you can look at your calculator, you can see, well, math, probability, the same place we went for our factorial, and PR is a permutation. And all you would do is put in your N, which is 11, your R, which is 8, and hit enter.
How do you do that on like a really old and crappy calculator?
I believe what you have to do is you have to put 11, and then go to math probability, hit it, and then hit 8. So if you have an older calculator, what you're going to do is you put your N in, then you're going to hit NPR, then you're going to put your R in. Okay? Is that yours back there?
What?
Do you get it?
It's just weird when I put it in beside itself, it'll say answer, and then hence NP.
Okay.
You get it clear.
Did everybody figure out how to work the calculator to do a permutation?
Yeah.
Yes? No?
It's not working.
It's not working. Gucci, you got it? If you can't figure it out, let me know.
I know how to do it.
I believe you. Alright. You got it? Yeah? Okay. Hey guys, listen up here. So, example 1. A group of 5 teens went to a movie theater. They found a row with 7 empty seats. How many different ways can the teens be seated in the row? How many different ways can the teens be seated in the row? So there's 5 teens, there's 7 empty seats. Alright? So if I'm going to do my permutation, I'm going to do 7P5. The bigger number should always be on the left. Right? Otherwise it's not going to work.
Why?
Because then you're choosing
Otherwise it's
7 things for 5 spots.
Okay.
Which, that can't work out, right? What?
turns out to be 0.
When you do this?
The other one.
The other, yeah, it's 0 because you can't do that. You can't choose 7 things for 5 spots. So the bigger one, right, there's 7 seats and we're choosing 5 of them because there's 5 people sitting in them. Does that make sense? So the one on the left is how many you have and the one is how many you're choosing. So 7P5 is going to give us what? How many different ways can they sit in those seats? 2,520 ways. Does that make sense? What was your question, Tobias? If you go math and probability, it's the second one down.
Yeah, I saw that, but I want to do like
Well, then we would, it depends on if you have an older one or a newer one.
an older one.
So then you're going to do 7, math, NPR, 5, and then enter. Okay? Alright. Example 2. We decided we only want to put 3 of our 5 trophies on that shelf. So put 3 out of the 5 trophies on the shelf. How many different ways arrangements can we make? Guys, those key words are going to be super huge in this day. Right? It's going to be really tough when we start talking about combinations as well, to decide which one is which. Like, I struggle with it a lot too. Alright? Ordering matter, order not. If it says the word order, we know it's going to be a permutation. If it says arranges, it's going to be a permutation. If it's going to be a lineup, it'll be a permutation. If they have certain positions, it'll be a permutation. Whenever order matters, that's when we know it's going to be a permutation. Alright? So like words like arrangements are huge words telling me that I know it's going to be a permutation. Okay? So I know I have 5 trophies to pick from, and I'm choosing 3 of them. So it's 5P3. Right? How many I have, how many I'm picking. 5P3. What do we get?
60. Jinx.
60 arrangements.
What? Yeah.
Does that make sense so far? Yes? No?
Yeah.
Do you have any questions so far?
No.
I think we ought to keep rolling.
Let's just,
'Cause I got some homework to do.
No, we'll talk about combinations now. So combinations, if order does not matter, right? Oh, it says down here too. An arrangement or listing in which order is not important is a combination, right? So permutations, the order matters. Combinations, order is not important. Right? That's the big thing. That's a big difference between the two. So when we're doing a problem, we got to figure out, does the order matter or not? So I know if I do a combination or a permutation. Now, the formula for a combination is n factorial over r factorial times n minus r factorial. Now, just like a permutation, there's a way to do this in our calculator that I'll show you in a second. We're not going to use the formulas very often. 99% of the time, I'm going to do it on the calculator. Right? I'm not going to expect you to memorize the formulas. If you want to learn them, you can. They're great formulas, but I'm not expecting you to memorize those. Okay? So same thing, if you go into your calculator under probability, right underneath NPR is NCR. Right? Same thing can be written as NCR. And that's how you're going to find it in your calculator is NCR. Combination, n things chosen r times.
is
All right.
the bigger one first or what?
What?
Is it the bigger one first?
The bigger one's still first, yes. Alright, so let's play lottery. The Wisconsin Pick 3 lottery is worth $500,000. Each person can choose 3 numbers from the numbers 0 through 9. How many possible combinations are there? In this problem, order does not matter. It doesn't matter if you pick 0, 2, 4, or if you pick 2, 4, 0. You still pick the same 3 numbers. Right? Doesn't matter which order you pick them, you're only picking 3 numbers. So how many possible combinations are there? Well, how many numbers do we have to choose from? 10. And it's a combination because order doesn't matter. And how many are we picking? 3. So 10, C, 3. If you wanted to write them out, you could. You could go 10 times 9 times 8. Should still get you the same answer. What do you get? So if we put in our calculator,
See,
10, C3. What do we got 120? There's 120 different numbers we could pick, different arrangements we could pick. Okay? Okay, I think we have 2 more examples and we're going to do, just pick which one is which. So, Yo-Cool has 12 flavors of frozen yogurt to pick from. If you want to choose 2 flavors, how many possible combinations can you make?
Is there Yoko in the existing one?
How do you know that?
Is that lived by them?
How do you know there's not a different one?
I don't know.
There could be more than one location.
What?
There could be more than one location.
Yeah, but there's only one.
Yeah, you don't know that. Alright, so there's 12 flavors. And you want to pick 2 of them. Does it matter if I pick chocolate chip and then cookie dough or cookie dough chocolate? No, it doesn't matter, right? The order doesn't matter in which I pick them, so it's going to be a combination. So I have 12 to pick from. It's a combination and I'm choosing 2. So 12C2, there are 66 different combinations I can make. Alright, example 2. A pizza parlor serves toppings of pepperoni, sausage, Canadian bacon, mushrooms, onions, peppers, and olives. Matt chooses 3 different toppings. How many different 3-topping pizzas can he order? Well, does it matter if I pick pepperonis, onions, and then sausage, or onion, sausage, and pepperoni? No, the same stuff goes on the pizza. It doesn't matter what order I pick it, it still all goes on there. So it's a combination, order doesn't matter. How many toppings do I have to pick from? 7. And combination, I'm choosing 3. So 7, choose 3. There are 35 different 3-topping pizzas we can make. All right? Any questions? Last part here. Combination and permutation. So what we need to figure out is each situation going to be a combination or a permutation, and it depends on does the order matter. All right. Kaden, pick a number.
6.
1, 2, 3, 4, 5, 6. Mason, first one. Our classroom seating chart. First of all, does the order matter?
No.
In this class, technically no, but in a seating chart, does the order matter? If I put you guys in a seating chart, does the order you set matter?
Yes.
Yeah, because I'm putting you in certain spots, right?
Oh.
Right? A seating chart has certain spots, so the order matters. So, would it be a combination or permutation? Permutation. I'm just going to write P. I don't want to write the whole thing out. So.
Patrick.
All right, Mason, pick a number. 8, 9. Dom, the batting order of the Brewers. Does the order matter? Yeah, so it's a what? Permutation. Good. Right? The order matters. You bat out of order, you get out. Dom, pick a number. 1. Page. Page P. A hand of 5 cards from a deck of 52 cards. Does it matter what order you get those cards? No, so it should be a combination. Right? Order doesn't matter. Alright, Paige, pick a number.
3.
1, 2, 3. Stetner,
Yes.
a 7-person committee for prom. Does the order matter? No, it doesn't. Now, if it said that there's going to be certain positions on that committee, like a president, a vice president, treasurer, things like that, then the order would matter. But because it doesn't say anything like that, our order doesn't matter, so it's a combination. Stetner, pick the last number, please.
You better pick 2.
6.
You already picked 6.
Fine.
Pick one.
5.
Yeah.
Levi,
Oh, yeah.
10 books on a library shelf. Let's think about it. In a library, does the order matter what the books are put in?
Yes.
It does, right? They have systems in libraries that to order books. So is it a permutation or combination? Permutation. Very good. All right, so biggest thing, decide order, does it matter, does it not? It's permutation combination.